We're going to do a few partial derivative example problems. So first, given z is equal to x squared y to the sixth over 3, you may be asked to find the partial derivative of that function with respect to x. So first of all, a basic derivative using the power rule we can write as the derivative with respect to x of x to the n is equal to n times x to the n minus 1. So that n is just saying any number there will be moved down to the front, and then in the power it should be subtracted by 1. So in practice, if we write that out, we can say that the derivative of z with respect to x is equal to the derivative with respect to x of the function z, so x squared y to the sixth over 3. And this looks complicated, but if we take out the y to the sixth over 3, we can just treat that out as a constant and move it out here. It becomes a lot simpler. So we'll write that. And then from here we can just use the power rule, and we get that the derivative with respect to x, we bring the 2 down, x to the 2 minus 1. That's supposed to be a parentheses. And then from there we can write out the answer. So the derivative of this function z with respect to x is equal to y to the sixth times x to the just 1. Can't forget the 2 out there, and then 3. And then the partial derivative with respect to y, we can write that out like this. We say the partial derivative with respect to y of this equation and again we first look for constants that we can pull out. So since we're taking the derivative with respect to y, we can take out everything else that isn't directly tied to y and can just be treated as a constant. So we have x squared over 6 would be our quote-unquote constant. And so the derivative of y to the 6, just using the power rule, we can write as 6y to the 6 minus 1. So the derivative of that function, that is just terrible. The derivative of that function with respect to y is equal to x squared, 6x squared. I realized I put a 6 there instead of a 3. 6x squared times y to the fifth all over 3. And that can be reduced to 2x squared y to the fifth. And so that works well when you have the x and y in the numerator, but what if you have one of those in the denominator? So we'll go over that example. So given y equals x over, or z equals x over y, find the partial derivative of z with respect to x and y. So we'll start with the x. That is in the numerator, so it should be the easiest. So that can be rewritten as the partial derivative with respect to x of x over y. Now you'll notice that we can pull out 1 over y because it is a constant. And then we just need to take the derivative with respect to x of x, which is super easy. It's just 1. X to the 0 is 1, so we're just left with 1 over y times 1, giving us the answer that the partial derivative of z with respect to x is equal to 1 over y for simplification. Now, because z is in the denominator, we can actually rewrite that and move it into the numerator as y to the negative 1. So this equation can be rewritten as the derivative with respect to y of x to the y minus 1. And you'll notice that we can pull out that x because it can be treated as a constant for now. So we're left with the derivative of y to the negative 1. And just using the power rule from before, we get x times y, x times negative 1 to y, negative 1 minus 1. And this can be rewritten as negative x y to the negative 2. And that can just be rewritten as negative x over y squared. Now what if you have a square root? So first we will solve for the derivative, or the partial derivative with respect to x. So that will just be the derivative with respect to x of x square root y. Now we can pull out the square root y because we can just treat it as a constant. And then we just need to take the derivative of x with, or the derivative of x, and that is just equal to 1. So we're left with the partial derivative of function w with respect to x is just equal to the square root of y. Now for y, we can rewrite this. So the partial derivative of this function with respect to y, we can rewrite it as x times y to the 1/2. And then we can just pull out our quote-unquote constant of x and use the power rule for derivatives to solve for this. So the derivative with respect to y of y to the 1/2. So that would just be equal to x times 1/2 y 1/2 minus 1. And you can see that would be 1/2 x y times, or to the negative 1/2. So the derivative, the partial derivative of the function w with respect to y would just be equal to x over 2 root y. Now for the last one, we're going to introduce a new function. It is known that the derivative with respect to x of the sine of x is equal to the cosine of x. And the derivative with respect to y of cosine of y, it's a terrible y right there. There we go. is equal to negative sine of y. So keeping this in mind, when we take the partial derivative of q with respect to z in our equation, we will just take the derivative of z, sine of z, and then we'll write this as our constant, the cosine of f. So taking that cosine of f out and taking the derivative of z, we're left with the cosine of f times sine goes to cosine when you take the derivative, so just cosine of z. So the derivative of the function q with respect to z is just equal to the cosine of z times the cosine of f. Now, the derivative of function q with respect to f, we will treat the sine as a constant now, so we'll say the derivative with respect to f times sine z, and the cosine f will be our variable. And so using this rule established earlier, we will get negative, we'll write the sine first, we'll get sine of z times negative sine of f. So the derivative of the function q with respect to f is just equal to negative sine z times the sine of f. And yeah, that's how you do these partial derivatives.